Various methods are used to make fiber-reinforced composites based on their size, purpose, and materials. One common method is called resin transfer modeling, or RTM. In RTM, dry fibers are placed in a mold and resin is injected while the specimen is under vacuum pressure. Then heat and pressure are applied to help the resin harden. A challenge with this method is preventing the formation of air bubbles, as they can disrupt the resin flow through the fibers and affect the quality of the composite. Another popular method used today is called pre-preg. In this method, the fibers are partly cured in resin. After that, they are cut and placed in a mold for complete curing under heat and pressure. So in this method, pre-pregs are ready to be placed in the mold without needing extra resin. The method provides accurate resin content and consistent quality, although it can be more expensive than RTM. Now you have learned about RTM and pre-preg. Both require high-quality curing to enhance composite quality. But why is curing so important, and how is it performed? Let us explain. Do you know what curing does? Imagine a resin in the pre-gel state, which is like a liquid and can flow through fibers. Can we use the composite in this state? No, the resin needs to be cured to pass the gel point. At this point, it becomes a gel-like material. The step is important as it helps the resin start to solidify, but complete solidification is not achieved at this stage. After further curing in the post-gel stage, the resin loses its ability to flow, becomes stiff, gains strength, and completely hardens into a solid phase. Now the composite is ready to be used. But do you understand why a careful process of curing is important? The first reason is that curing should be done with the right amount of resin, specifically a low amount. Note that excessive resin injection during curing can impact the composite's quality, potentially causing problems like voids, brittleness, or weaker mechanical properties. Additionally, the surface finish quality of a composite depends on factors such as the quality of the mold or the tools used during the curing process. Ultimately, the curing quality determines the overall quality and performance of FRCs. Now you might ask yourself how the curing process is done. Let us explain. One common method used today is the autoclave curing. In this method, a pressurized chamber applies both pressure and heat to the specimen. The method offers benefits like creating high-quality laminates with low porosity and strong mechanical properties, but it is expensive and requires large and complex equipment, as shown in the figure. The second commonly used method is oven curing. In this method, a regular oven provides heat to the laminate. However, it requires a vacuum bag to apply pressure and remove air from the composite for better quality. It is more cost-effective and simpler compared to autoclave curing, but the composite might have lower mechanical properties due to increased porosity. In this figure, you can observe the process of curing a laminate in an oven.